If you're coming to iOS from web development, say you've used JavaScript, Python, Perl, PHP, or Ruby, you're going to find that some things are the same, but many things are new or different. The things that are the same are things like assignment and arithmetic operators. You'll find your old friends add, subtract, multiply, divide, modulo, and, or, etc. You'll find familiar statement construction in Objective-C, if, for, switch, while, do while, and return, break, and continue. You'll also find functions with parameters. But then you start to see things that are very different. All development is done in an IDE, in this particular case Xcode, which is free from Apple. But it includes not only the editor and compiler, it includes a debugger, profiling tools, and code completion. And while you could use a text editor and command line tools to build iOS applications, you really don't want to do that because all the productivity and all the tools for doing it live inside Xcode. To run on an iPhone, iPod Touch, or iPad, you have to join Apple's developer program, which costs $99 a year. You can build and run in the iOS simulator, but that's not the same as running on a device, and you really don't want to ship your app by only testing it on the simulator. You must test it on some kind of device. And a very big difference is you can only ship through the Apple App Store. Apps require approval by Apple. You must follow the rules about using the SDK, and updates or shipping, once you're done, requires days and sometimes weeks to release. So the rapid turnaround time that you might be used to in web development, where you can simply put something on staging, test it out, and then roll it into production 5 minutes later, is not what you'll find in the iOS world. So therefore you must do more upfront planning, you must do more extensive testing, and you must factor in the delay of getting your product in the store. And some things are new. First up, all variables must be declared. Second, strong typing is enforced. You get compile time checking, which can sometimes save you hours and hours of time, but it also means you have to do explicit conversions. No longer can you simply use a string that contains numeric characters where you mean a number. If you have a string containing numeric characters, you must explicitly convert it into some numerical form before you can do computation with it. All code in iOS is compiled. This means you don't get any runtime expression evaluation. And finally, your source code for every single class is split up into two files. You have header files, which have an extension of .h that contain declarations only, and code files with an extension of .m that contain both declarations and statements. Some things that are new, compared to some of the web development languages, in Objective-C you have true objects. This means you get inheritance. The classic example of that is that you have an animal class that defines a legs method that returns 0, and then you override that with a cat class that has a legs method that returns 4. So therefore, any place you have a reference of something of type animal and you ask it how many legs it has, if it's actually a cat object, it will return 4 instead of the 0. You have public and private member variables. And you also have public and private methods. You also have protocols, which in some other languages are called interfaces. This is a declaration of a specific set of methods that a class must implement in order to be said to conform to this protocol. That means you can have multiple implementations that all conform to the same protocol, and any time you need to be able to have a class that has a specific protocol, you can use any of those implementations in that place. In some scripting languages, you've already seen callbacks. In iOS and Objective-C, these are called delegates, and they're used very frequently, and they're also explicitly defined, and they're defined using these protocols. For example, when you build a table in iOS, every table in iOS conforms to a specific protocol that defines a number of callbacks that are made back to your code that handles that table to define such things as how many items are in the table and what should the content be for row X of the table. Another big difference between web development and iOS development is in the area of user interface construction. There's no markup. Everything is built in something called a nib file. A nib file is built using a tool that's built into Xcode called Interface Builder. Now you might see there the file says XIB. It's still pronounced nib, because originally these came from the Next OS, and so they were called Next Interface Builder files, or NIB. And then when Apple bought Next and created OS X, they changed the N to an X, but they still pronounce it nib. And finally, you use explicit access to UI elements as opposed to the DOM, where you look up things by name. Now it's true, You could add a name tag to every single one of your nib elements and go find it by name at runtime, but it's much more convenient to explicitly define reference variables in your class to say, I want access to this particular label, or I want access to this particular text field that's on the screen, and therefore you can access it directly. You don't have to go and look it up as you might inside of a DOM or with jQuery. Coming up, we'll get into a much more detailed deep dive into Objective-C so that you can understand how to use all the elements of the language. And we'll be using Interface Builder extensively as we go through examining each one of the controls in the iOS toolbox and how to use them to build a user interface.